Um, this is training on commissioning Discover lithium battery systems. We're going to be mainly looking at their integration with Victron, NOARC, and Cellectronic, and just the various closed loop and open loop configurations you can have with them, and a little bit of product knowledge and things like that as well. So we're also going to talk about some of the advantages of the Discover system, which is mainly in its sort of advanced monitoring and BMS. So in terms of the product range, it's a rack mount 19-inch battery, much like many of the other ones that you see on the market. It's 3 RU high, and they offer a range of cabinets. The most notable one is this one on the left-hand side here. They call this the slimline cabinet. It's IP54 rated, so you can put it outside, and it takes 6 batteries. And you can't really see very well from this photo, but it has bus bars in there as well, and a spot for the Link 2 device, which I'll explain what that is in a moment. But it's basically an external comms box, which does all sorts of great magic things. And you can fit that inside. It's a nice slim design, so you can fit it either side on or front on outside. And you can't really see from here, but it actually has a nice sort of angle on the roof there as well. So it looks a bit more stylish than your average box type enclosure. Obviously, there's a lid that goes on the front here. You can use this inside as well. If you're doing indoor stuff and you don't want to use the 6 battery slimline cabinet, you can use the quick stack racks. These are pretty much the same as other ones you get from manufacturers like Pylon Tech. You can put up to 6 batteries stacked like this in a quick stack rack. And then you can also use the Discover combiner. The combiner box allows you to combine 6 or 8 batteries in parallel. It's got an internal bus bar, and then you run that back to your main switch. And so these little quick stack racks, if you're not familiar with the Pylon Tech ones, it's just a metal bracket that fastens around the battery and allows you to stack them up on top of each other, and you'd bolt it to the concrete or something like that. They're quick and easy, and they're relatively cheap, and they're good for installations inside a container, for example. And then you've got we offer this 8 battery cabinet, which is just a standard data rack cabinet. You can fit up to 8 batteries and a combiner in that, and it's IP20, so it's just for inside use. We also have these cabinets available for external. This is quite good for, say, you're using a NOARC on a grid tie system, and they just want to do a bit of load shifting, so they might only have a few batteries. We've got the twin cabinet. It takes 2 batteries, has a little bracket inside this 600 by 600 enclosure, and that's IP65 rated, and it's pretty affordable. So it's a really nice, quick and neat solution you mount on the wall. Then we've got these 2 cabinets here, which take 4 batteries. One of them is 1 meter by 1 meter by 300, and it comes with a Victron Lynx combiner, and it's IP65. And then we've got this other one we call the quad tower, and that takes 4 batteries, IP65, and it's a bit more similar to the Pylon Tech cabinet, if you're familiar with that one, the WD 1380, I think it's called, something like that. And that stacks them vertically, 2 deep, and then another 2 deep at the top. The combiner box I mentioned before, it comes set up for 6 batteries, but we can add another 2 cable sets to it to make it take 8 batteries. It takes up 2 RU rack spaces. In the picture here, it looks like it's got a breaker on the front, but it doesn't actually have a breaker on the front because they were designed for the US market, and they only break the positive, which is no use to us over here. You need to break the positive and the negative. It has like a rat's tail that comes out the back, so it has all the cable connections come connected to the bus bar that's inside there, and so you just slot it in to your racking, and then you run the cables. through however you're doing it to the front of the batteries, which makes it a bit quicker and easier because you don't have to attach it to the bus bar. It has this remote on-off switch, and I'll cover that when we look at the battery itself. It works with the quick stack rack and the 8 battery cabinet I mentioned before, but it's not needed in the slimline cabinet because it's already got the bus bars. In terms of the actual batteries offered by Discover, is the AES Rackmount, and this one is available now. This is the main one that we've been selling, and it's very well received. This is a 5.12 kilowatt hour battery. And then we also have the Helios, which is a new product which is coming soon. Again, it's a 48 volt battery, but this one is IP65 rated and it's 16 kilowatt hours. So you don't need a cabinet for it. You can use it indoor or outdoors. You can have as many of them as you like. And it's going to be at a great price point as well. The features of the rack mount battery. So you've got positive and negative Amphenol connectors on the front. You've got a 2-pole breaker here, 100 amp breaker, which meets CC and best practice guide specifications, but most of the time you'll need an additional external breaker because you're going to have the battery inside some sort of cabinet, so it wouldn't be readily accessible. But in some scenarios when you didn't, if it was readily accessible, it could be an isolation device because it's 2-pole. There's an on-off button here. So when you press this on-off button, there is a contactor inside the battery on the BMS, and that turns that contactor on and off. And that's an interesting point about it because a lot of other batteries, the BMS just turns off the supply electronically with FETs. It doesn't actually mechanically break it. Whereas the contactor inside the Discover batteries has actually got 2 big contactors in series with each other. So when it's off, it's off. And that's its default state. The coil needs to be engaged by the battery for it to turn on. So it offers a lot more protection over and above what the breaker has here of any sort of short circuit. We've got the comms ports here. These are used to daisy chain the batteries together and then go onto the Link 2 device, which I'll discuss in a moment. And then you've just got a little earthing point here as well. It's important to notice that there's only one set of connectors. So unlike some other batteries which have a pair, which seems like a good idea, but actually now that the batteries are the size that they are, you don't want to daisy chain them together because the currents are too large for the cables. So you really need to take them back to an independent bus bar to manage all the currents correctly. Whereas there are some other batteries that still have the pair of connectors on the front, even though they've got quite large batteries, and it's quite a compromised design, really. Oops, going the wrong way. So the Link 2 communication gateway. So this is what is used to take all the data from the battery bank and put it all together. And it then will spit out whatever comms protocol you need for whichever inverter you're using. So it's really adaptable. Instead of just having a one-size-fits-all CAN bus output, it actually has a tailor-made CAN bus output for each inverter. It also allows a much, much higher level of monitoring than you'll see with, as far as I can tell, any other lithium battery product that's on the market. Nearly all of the other batteries will only give you the battery voltage, the current of the entire stack, and you'll get the maximum and minimum cell voltage of the entire stack and the state of health. Whereas with the Link 2, you can see each individual battery, its state of charge, its voltage, the current in and out, its state of health, its serial number. the maximum and minimum cell voltages, and then you can download the history for each individual battery as well. And I'll go through this and show you all that. But it makes an enormous difference for if you have a large amount of batteries. Say you're doing a big install in the middle of nowhere, and you want to make sure that's all working properly. When you plug it in and commission it, you can see all the batteries leveling out with each other, and you can see if any of them are not pulling their weight or not switched on. Whereas with the other systems, it's much harder to detect any of those issues until the battery actually sort of fails or has a warning light. So you have that overview, and there's an online portal which is being launched any day now, where you'll be able to see all of this online as well. But I'll come to this in a bit more detail in a moment. So the advantages of these systems is that with many batteries, you can only do closed loop designs, which means when if they lose their comms to the inverter, the battery system will stop working. Whereas the Discover systems can be used in open or closed loop, so they can operate independently of communication with the inverter, just like a lead acid bank, like Power Plus can, or they can be in a closed loop design. So you might want to go open loop because you don't want to include the Link 2 because you're on a budget, maybe just have one battery. Or you might want to do it because the inverter doesn't have comms, it's an older system. We had one with an older SMA recently where the comms were only designed for NMC batteries. So we ran an open loop scenario. Or if you're just not comfortable with that sort of thing, you prefer something like Power Plus, Discover is exactly the same. You can just run it open loop. Even if you're doing that, you could still install the Link 2 anyway and not have it connected to the inverter, so that you could have the online monitoring of the battery bank if you wanted to, and you can come and get the downloads of all the history data. So there's a question from Pedro that I hadn't noticed. Where would you locate the combiner in the rack? So what Pedro is asking is, let's go back. So if we're saying we're using a quick stack rack, you've got the combiner box here. Because the quick stack racks are only 6 batteries high, you can put it at the top or the bottom or the middle. You can do whatever you like, and the cables will reach all of them. If you were putting it in like the 8 battery cabinet, you'd put it in the middle, so you've got enough cable lengths to get to the bottom and the top batteries. If you put it at the top, it wouldn't reach all the way down to the bottom. But otherwise, when you're just doing the quick stack rack, you can put them wherever you like, really. So open loop means there's no comms between the battery and the inverter. The inverter charger just reads the voltage and current itself, and it decides when to charge and when to discharge. So most of us will be familiar with that. That's just like a normal lead acid type setup, and you've just got a fixed value for the current that you charge the battery at. And that's fine and works pretty well for most circumstances. When you have a closed loop system, that means that the battery bank is communicating directly with the inverter. So what it's doing is it's telling the inverter, this is the maximum voltage I want to be, and it's telling the inverter, this is the maximum amount of charge current I want to receive, and this is the maximum amount of discharge current that I want to give out. And those values are dynamic. So what that means is that as it gets towards the bottom, it might throttle off that discharge current because the battery's getting empty. And as it gets to the top, as the battery gets full, it might throttle off that charge current or reduce that charge voltage as the battery gets full. The advantage in doing this is it means that when you're in the middle of the range, that the charge current and the discharge current can be greater than when it's open loop. You're going to have to be more conservative with your values because they've got to be suitable for the entire way through the charge curve rather than just in the middle. So you can get a bit more power out of the batteries if you're having a closed loop scenario. A lot of the time, that's not going to make a huge difference, but it is a design factor that you might need to take into account sometimes when you have not many batteries. The other big advantage to closed loop is that it allows the batteries to instruct the inverter to do dynamic charging. And so what that means is that when the batteries get towards the top of the charge cycle, they then want to balance the cells so that the cells are all at the same voltage point. And it does that towards the top of the charge cycle. And so it wants to slow down that charge cycle so that it can do the balancing. So with open loop, it's not able to do that. The inverter is just going to charge it as quickly as it can. Whereas with closed loop, if the battery bank wants to, it can slow that charge rate down in order to allow it to have more time to balance itself. And that's going to mean that you're going to have a better health of the battery system going forward, because it's going to be more balanced. It also allows you to pass communication to the inverter, which is then going to go on to that inverter's monitoring platform. So if we're talking about Victron, for instance, we're going to get not just what the Victron inverter thinks that the battery voltage is, you're going to get what the battery thinks the battery voltage is and what it thinks its charge current is, as well as any warnings and alarms that BMS is going to send through there, and maximum and minimum cell voltages. And all of that stuff is available in the Victron portal. So that's pretty important, because when you're troubleshooting a system, it's pretty important to see what the inverter thinks the voltage is and what the battery thinks the voltage is. And if those are drastically different, that might mean that you've got a cabling problem, for instance. If the voltages are pretty much the same when there's no current, but then when you start putting current into the battery, the voltages get wildly away from each other, that means you've got high resistance in the circuit. And that's pretty important just for all monitoring and seeing how the system goes. Of course, if you're doing an open loop, you can do something similar to that with something like a smart shunt as well, which is down at the batteries, or the voltage sense cables from a Victron inverter. So the C rating of the battery is 1C. So the maximum that it will do is it's a 100 amp hour battery, so it will do 100 amps. This means in some scenarios you can have a smaller battery bank, like a hybrid generator or something like that. But in general, you're not going to design it to do 100 amps on a continuous basis. You're going to continue. It's going to be more like designing it for about 70% of that. Just because you don't want to run it at that top threshold. And of course, it's got surge capabilities over and above that as well for 10 seconds. So in terms of the monitoring, what I might do is just switch over to the link device to show you how that works, rather than using my slides I've got here. So just give me a moment while I change that over. Okay. So what we've got here is link access. So this is a program that you download from Discover and you load up on your PC. You plug a USB cable from the link 2 into your PC, and then you can see what is happening with this BMS. And this is connected via a Cat5 cable to the top battery of the stack, and then the rest of them are daisy chained down from there. So you can see in here, we're just looking at the link. You've got these tabs on the left-hand side. We're looking at the link device itself. So we can see the hardware version of it, the serial number, the firmware. there's firmware updates come out reasonably regularly from Discover. We've got the CAN settings here, and I'll go through that when we go to actually do a commissioning example. Relay settings, I'll get to those in a moment. But the main thing we're interested in as far as the advantages of the system is this section here, the battery system. And so this is the monitoring part of it. So you can see here, I've got 4 batteries, and instead of just getting the average values of the whole stack, I've got each individual battery. I can see the state of charge of each battery, see the voltage, and I can see the current. And because this is a simulation here, they're all identical, but most of the time you'll see slight variances in the amount of current which is going in or out of all these batteries that are in parallel, and they'll all have a slightly different state of charge. And depending on the health of the bank, they'll be closer or further away from each other. So it's really valuable data. You can also see the charge and discharge kilowatt hours. So you can actually see how much work each battery in the stack has done over its lifetime. So again, if you were troubleshooting a battery bank, if you saw one of these values was much greater than the other, that would give you an indication that one's working harder and that there's some sort of an issue. Cell minimum, average, and maximum voltages, the spread, the temperature of the battery and of the board, the firmware, and then really interestingly here, you've got the data logs. So you can download all the data logs. Once you've got a battery that's been used for a while, it actually takes a pretty long time to download these logs. It's a massive CSV file because it takes a reading. I think it's 4 times a minute for the entire history of that the battery has been operational. So you get a really high resolution of data for each individual battery. So you can really go into a lot of detail about what's happening with the system. Again, if you've just got a couple of batteries, that might not be particularly useful to you. But if you've got a large, a container full of these things out in the middle NT, it's really valuable. If you've got somebody in the field and get this stuff and send it to you, as soon as you've got the cloud, you'll be able to look at a lot of the stuff online anyway. But you can just get them to send you this data and you can look into great detail about what's happening with it. And it's just not available from anybody else, as far as I know. You have the main dashboard here. And this shows you, this is what would be sent to the inverter. So this is the average state of charge of the entire stack, the voltage, the current coming in and out, all of that general information. Over here we have relay settings. So the Link 2 has another great little feature that you don't see anywhere else, which is it has these relays on the side of it. So you can use them for things like configuring a generator, stopping and starting a generator. And the reason that might be useful is that it allows you to start up something based on the battery rather than based on the inverter. So in a black start scenario, instead of having, say, the Cellectronic start the generator, if the Cellectronic loses its mind and stops functioning, the battery can start the generator and you'll still have power on site. Even if the pass-through is not working on the input side of the inverter, there'll be power. So that's pretty useful. In Victron, because the servo is powered on the DC side, it's not as much of an issue because even if you lose the inverter, it would still start the generator. But with the other inverters like Cellectronic and NoArc, I think it's a good alternative to their inbuilt generator. And you can do quite a bit more with it as well. So let's have a look. So it has 3 relays that you can use. And you can set things based on cell temperature, cell voltage, state of charge, current, and then it has a specific one for generator start stop. Maximum runtime, it has a quiet time feature. Exercise generator.
Not sure if that's updated.
Is it updating on yours?
No.
Sorry, everybody. Sorry, just a few technical problems. Won't be a moment. Okay. It's not doing the pop-ups. Okay, sorry. I think I know how to fix that. Okay. So I'll start again. So when we're in here, we press this cog relay settings, and then up comes this menu. You've got the 3 different relays, and then there are various parameters that you can set that relay to be triggered by. It's a normally open, normally closed relay. And the most common one you'd be using would be this generator start-stop relay, which can be determined by state of charge. And then you've got generator, exercise generator, quiet time, and max run time. You can use all 3 of these. It's not either or. All of these options are available. So it's a pretty comprehensive generator start-stop setup, nearly as good as the Victron one, I think. So that's pretty useful. And it's just these little green connectors which are on the side of the Link 2 device. So I'll go back to my main presentation now.
You could do a dump load or run some other loads.
Absolutely. This is an example of the data that you can get out of it, the CSV. And you'll get one for each individual battery with a serial number in it as well. So you can see this massive amount of data there, and the fault status of the relay. Yeah, it's a huge amount of data. It's really great. And then you also have the Link portal as well. So this is a web interface, which is pretty similar to the interface I just showed you on the Link 2 device itself. It will have the history of the voltage and the current and the state of charge of the battery bank, and you'll have that same battery list which I showed you. It'll give you the hardware version of the Link 2. It will give you the CAN settings, which I'll show you how to set those, the relay settings, so you can remotely change all those settings. Everything is pretty much the same. The only thing it doesn't do is give you that really high resolution download here. That might be coming, I'm told, but the reason for that is because these files get really, really big. And so it's just a bandwidth issue of being able to pipe that through everything, through the servers and back down to you. Incidentally, if you don't have a link to, the batteries have all of this stored in them. So it's not being stored in the link to device. It's actually stored in the battery. So if you have a site that is open loop with no link to, you can take a link to with you and get all this data out of the battery. And this is just a little comparison to say like the PylonTech software. So this is Battery View, which is a PylonTech diagnostics tool. If you're familiar with using it, it's pretty difficult to get it working. A lot of time the cables just that you get from PylonTech don't work, and it can be a real headache, even if you've done it lots of times before. The drivers don't work, but if you do get it working, you can get quite a bit of information out of it. But again, it's really only averages. You don't get the detailed information that you get from Discover, and you'd have to talk to each battery one by one, which take forever, and it's not available remotely. So it's really much more sophisticated than anything else. This is all just what I showed you before. You can generate a diagnostics report from the link to, and that's something you could send to Discover in the event that there's some sort of system failure that you don't understand. It's pretty unlikely you have to use that, but that's a spreadsheet, and it's got quite a lot of information. It can tell you how many times the system is shut down, what caused it to shut down, all sorts of things like that. And you can download all the data logs in one go. Let's skip through all this. These are just my backup settings. Oh, yep. Sorry, something I forgot to mention is that also on your link to, if you click support, then there's just direct links to new battery documentation and firmware, and technical support, product registration. All of those links are just directly there. The reason that, well, one of the reasons that they have the link to device is that they found that when they're releasing firmware updates, it means if you change the batteries, you have to get them retested. And so what they do is they have a lot of the smarts in the link to, which is external to the batteries, so they can make new developments and changes to the link to without having to go through the new testing procedure, which is a big advantage over everybody else who, if they want to add a new feature, they basically have to make a new battery. So it might only happen every 5 years, and it doesn't get rolled back to all the previous systems. Whereas with Discover, if they add some new feature, everybody gets it, a bit like how Victron does it.
When you're talking about testing, you mean IEL or internet testing at a test house?
Yeah, like UN 1973 or something like that, which is very expensive. So they're not going to do that twice. Nobody's going to do that twice because it costs too much money. So it means that they don't release, updates or improvements for their batteries after that. Whereas with Discover, because they've got it external, they can do as much of that as they like, add support for new inverters, add new features. It's really great. I'm just conscious of the time, so I'm going to go a bit faster. Skip through all this. Link portal, already told you about that. So commissioning. So we're going to talk about Victron, NOARC, and Selectronic. We're going to be talking about closed loop systems, because the open loop systems are just exactly the same as a lead acid type battery or Power Plus. You just plug in the parameters that are in the manual for Discover, and off you go. There's not really much to it. So we're going to be talking about closed loop. So what you need to do for closed loop is, the first thing you need to do is you need to set up your link. So I'm just going to share the link. Again, more successfully than last time. Have a look at this. So what you need to do Okay, so what you need to do is your you're in link access, you've connected that by USB to link access. It doesn't matter if your batteries are connected or not. The link device can be powered by USB or powered by the batteries. You're going to go to this tab on the left, link, and then you're going to go over to CAN settings. And you're going to hit this cog here, and then you're going to select a protocol. And so there's lots of options here. We've got Victron, we've got SMA, we've got NOARC. You select whatever protocol you're using, and then you select a baud rate. And then over here, it has a little description that opens up here and shows you the pinout, which you can change inside of it. So I'm just going to show you that very quickly, how that works. Okay, so we've got a little camera here. David's going to bring it over. And you can see this is a link to, which I've taken the cover off. And in here, we've got these jumpers, which you can move about. I hope that was it. I'll show it a bit more clearly. And you just move these according to the pattern that's in the diagram. So for Victron, you're putting the low at the top here and the high just below it underneath there, and the ground in that position there. If you were doing, for instance, NOARC, that would be in the middle here. This is the default. It ships with this arrangement. And actually, when you're doing Victron, instead of changing these pins, you can just use the Type A cable, which will transform them from being on pins 4 and 5 to being on pins 7 and 8, which is what Victron require. So you don't actually need to change the pins for this. So for NOARC and Victron, you don't need to go through this process unless you want to use a normal cable. For Victron, for NOARC, you can just use a normal RJ45 cable anyway. It's only for Selectronic, which have their pins on 1 and 2, that you need to move these jumpers down. But you do need to set the appropriate protocol in here, and then set the baud rate. Most of the time, that's going to be 500. With Victron, you can use 250 or 500, and I'll show you how to do that in a moment. You save that. So if we're doing, I'll do an example system here. If we're doing Victron, you're going to take an RJ45 cable from the top battery into the Discover, and then from the Discover into one of the CAN bus ports on your servo. You can see here, we've actually got it coming out of the combiner box, because the combiner box has the a set of RJ45 plugs, allowing you to daisy chain through the batteries as well. And it also has an on-off switch on the combiner box, which will turn the rest of the stack off and on. That's a state flip button. So it just means that when you press it, if everything's on, it'll turn them off. If everything's off, it will turn them on. So if you had half of them on and half of them off, it would just reverse the two like that. The half on and half off, the other way around. So I will show you inside a Pictron remote console. So I have to come back to that, I think. So we'll do no arc. So no arc is the same thing. You're going to go out of the top battery into your Discover link and then into the no arc. You're going to set the CAN bus ports in the no arc. And then you're going to go into the CAN bus port, which is here. So as long as you've got the baud rate set correctly, in you've selected no arc in the link to device, and you've got the pins correct, which if it just comes standard, you just use a normal Cat5 cable, and you put it in there, and it's just going to show up straight away. You're then going to go into battery settings, and you're going to turn it on to lithium mode. If you were doing an open loop, you would use battery voltage. You're going to put the battery capacity in. You can put these max charge and discharges in here, and they're basically going to override what the battery is asking for, only if they're lower than what the battery asks for. So if the battery is broadcasting a maximum of 200 amps charge, and you put 135 in, it will only charge it at 135. But if the battery is saying only give me 100 amps, it won't charge it at 135. You can then set the shutdown, restart, and low battery warning voltages. Again, these are independent of what the battery is going to do. The battery is going to shut down. I think I've taken one down to about 1% before, but you wouldn't want to design your system that way. But this is what the inverter is going to do, and this isn't really specific to Discover. This is any managed battery with a no arc inverter. If you were doing open loop, you would put all these charge settings, and you can see there's an excerpt here from the manual into there, just like you would lead acid. You want to have this enabled in the advanced function menu in NOARC, which is the BMS error stop. What that means is if you don't have that enabled, there's a chance that the inverter is going to keep doing whatever the last command from the battery is. If the battery loses communications, that's a NOARC thing. Other inverters behave differently. So you want the inverter to shut down when it loses communications. So that's what you have here. If you're in Victoria, if you're anywhere but Queensland with a NOARC inverter, you want to have DRM switched off as well. But we'll cover all that in the specific NOARC training that we're doing. For Selectronic, Discover is now on the Selectronic wizard. So we'll open up SP Link. There we go, we've got SP Link here, new version of SP Link, came out just recently. we go to our site configuration wizard. Say, give our site a name, Discover number 101, single inverter. If you had your Selectronic on site when you were doing this, you could connect it by USB, or if you didn't have it connected, then you just do a manual configuration. Select your inverter from the list. We're going to put a 481 in. Go next. And then you select which battery. And so you've got all the different manufacturers here. We'll select the Discover rack mount. And that's going to tell you the minimum number of batteries that you can use with the inverter that you selected. So it's saying that you need to use 3 batteries for this inverter to get the maximum output out of the inverter. And then after that, the rest of this is just your normal process that you go through to configure a Selectronic. It's going to put all of your charge settings and CAN bus settings. It's all done for you. So as long as you've got the Discover Link 2 set up to the Selectronic setting, and you've got the pins in the correct configuration, then this will just all work. You could make up a custom cable if you wanted to, instead of changing the pins over. I think it's easier to do the pins. I didn't do a very good job of showing it to you before. Sorry, the camera was a bit dark, but it's pretty easy to change them over. But if you're more comfortable crimping cables and changing the pin out, then you can do that. You have to consult with the Selectronic documentation for the pin out, or just look on the Discover 2 with that little map that I showed you. So I'll close this off, go back to presentation. Actually, let's see if the remote console is working. Okay, so now I'll show you the rest of the Victron commissioning. So you can see here that it is not discovering the Discover battery. So we want to go back into our Link 2 and check we've set this up correctly. So I've got Victron 500 baud rate. And like I mentioned before, all the other inverters have a set baud rate, but with Victron, you can choose between 500 and 250. The reason you might want to do that might be that you might want to have other things on the CAN bus. So if you had a Servo S, for instance, and you wanted to have VCAN connected MPPTs, you could have them on the same CAN bus network as the Discover batteries. Most of the time, you won't want to do that. So we're going to go into settings. We're going to go all the way down to services, down to our VCAN port. So this happens to be a Servo S, this particular model I have, so it only has the one CAN bus pair of ports. And I'm going to change it to CAN bus BMS 500. And now if I go back to my device list, you can see that the Discover is there. It's listing no data at the moment because I reset my Link 2, so it doesn't have any batteries connected to it. But if I just restart my simulation, then they'll show up. You won't have access to the simulation though, unless you apply for it. So you see, it's broadcasting its state of charge, its voltage, and its current. If we go into there, you can see much more detailed broadcast by the Link 2, including alarms. It's broadcasting what it wants its maximum charge voltage to be, and its maximum charge current and discharge current. And this will change. This will be dynamic. It'll be mostly the voltage you'll see change with Discover. Most other batteries controlled by current, whereas Discover actually controlled by voltage, which actually allows them a bit more flexibility. I've got all the information Yeah, and this all passes through to the Victron monitoring portal as well, anything that's in here. Again, if we wanted to do it at 250, we would just go down to services and change that to the 250 protocol and change it in the link 2 as well. When you're doing a Victron system, it's also a good idea to go into the multi-plus and the MPPTs and manually set the charging. The servo is going to force on DVCC, which means that it's going to be sending the charge parameters to the inverter and to the MPPTs. But in the event that they lose communication, then you want them to have the correct charge settings. So you would put in the charge settings from the manual for that. But there's actually a nice guide. If you just Google Victron Discover, there's an integration guide from Victron. Or you can go to the
and Discover has one on their website similarly to Selectronic.
And you can just go to find that. You can just go to the link to that support section, and that will link you through to where all that stuff is. But it's got all of the charge settings on here, just like they do for all the other batteries. It tells you about the pinouts you can use. It's a pretty comprehensive guide. But to get it working, you don't actually have to do this stuff. But it's a very good idea to do this. Take these extra steps. That's most of what you need to know. Does anybody have any questions?
While we're keeping an eye out for questions, and would it be fair to say that if people are doing their first install, we'll help them step through that over the phone?
100%, yeah. It's not particularly difficult. There's not many gotchas in it. The most difficult thing is probably changing the pins over and setting up the Link 2 device. But that's really only necessary to change the pins over for Selectronic. For NOAA, for Selectronic, no, that will be coming from Discover shortly, a firmware update. So at the moment, it's a good question, Pedro. At the moment, you just use the generic P-LV setting. So that is so you'll see it's quite interesting in here. There's actually lots of interesting options of things you can do. So you've got day, which is the same as NOAA and SunSync, Morningstar, but you've also got all these other kooky ones, Schneider. Generic P-LV, that is actually the Pylon-Tech protocol, which is used by lots of different manufacturers as their generic CAN bus protocol that they send out. So you just put it on that, and the Selectronic will read it. But there's a firmware update coming from Discover any day now, so we will say Selectronic, pretty shortly. The other stuff that's interesting in here is there's like the RV CAN instances, and so this would allow you to give each Link 2 connection to something like a servo a different instance number, which means you could actually have multiple Link 2s connected to a system. So if you want to do a really big system with Victron, for instance, then because there's a maximum of 32 batteries you can have connected to a Link 2. And if you wanted to do more than that, you could have multiple Link 2s and connect them using the RV CAN protocol and give each one its own separate instance. And this is actually exactly the same system that Victron has started offering themselves with the new Lynx BMS. What do they call it? NG, is it?
Yeah.
Yeah, the NG series. They have a maximum number of batteries you can attach to the Lynx BMS, And then after that, you have to have multiple BMSs connected to the servo to do larger systems. And it means you can have absolutely massive systems. So you can do that with Discover as well. Only with Victron, as far as I know at the moment, but that could come for everything else. When connecting the Link 2 to the internet, it doesn't have Wi-Fi at the moment. It just has an Ethernet port. You would, if you wanted Wi-Fi, you would just need to get one of those little Wi-Fi extenders from Officeworks that have a Ethernet socket on the bottom of them, and then you can join it to Wi-Fi that way. But we'll be doing a specific training on connecting to the Link 2 portal once it becomes available, which I'm told is, any day now. I think it's supposed to be next month.
Thanks, Gareth. It's just turned over 5 o'clock, so I guess if there's any last questions, we'll check the question comment section. But otherwise, it's been a very productive